Hello and welcome to PA211, week 6. We are over the hump officially for our half the class, and you guys are doing awesome. This is a math class, and so I know it can drag on some, but you guys are really putting in the work, so that's awesome. This week we are in chapter 18 and 19, and we are continuing to talk about flow rate calculations. Milliliters per hour, drops per mil. These are two different solutions that we're going to look at, or problems that we're going to look at, as we are in chapter 18, page 272 in your math for meds. And we go right into using ratio and proportions to calculate drops per minute and how to set that up. So, for example, we have an IV order is ordered to infuse at a rate of 125 mils per hour using a set caliber at 10 drops per mil. I'm on page 274, just reading right out of the book. We need to calculate drops per minute for the flow rate. So we start by converting our milliliters over hours to milliliters per minute. And so what we know about how minutes and hours are related is there are 60 minutes in 1 hour. So we set that up as a fact. So we do 125 milliliters per hour times 60 minutes to get us, divided by 60 minutes to get us a milliliters per minute. Now, we're not done because they want it in drops. So what do we know is the relationship between drops and milliliters? And so that is when we solve for x. They've put their facts that we know that there are 10 drops per 1 mil. That's what they gave us in our calibration. And then we need to know how many drops are in 2 mils. And so we set that up as a solve for x, and we get 20 drops. And then we can do 125 mils per hour using a set calibration of 10 drops per mil, set the drip rate at 20 drops per minute. And so that's how you can answer your flow rate questions. Just make sure that you know how to set up the solution, or the facts, that you know that there are 60 minutes in 1 hour and that we're looking for how many drops are in a mil, and we solve for x that way. And so there are multiple stepped problems. So if you are having trouble coming to the answer, make sure you're writing it all out so that I can see each step and if you've gotten it right. So then it's giving you a couple more questions here for you to work through. And then we're going to jump over to chapter 19. There's a lot of problems that you can practice on. So I love that about this chapter. Chapter 19 talks about calculating IV infusion and completion times. So the infusion time is calculated for each bag or bottle to be hung and infused. The largest capacity IV solution bag or bottle is 1,000 mils, but 500 mils, 250 mils, and 50 mil bags are also commonly used. So this is where we talk about calculating out the infusion time, dividing the volume being infused by the milliliters per hour rate ordered. And so your discussion question talks a lot about why we need to know the difference between milliliters per hour or drops per minute, and why is it so important. And so some of this will be able to, as you're going through these calculations, it'll show you that it can be over a 24-hour period if the nurse wants to hang a bag for 24 hours, or if you need to, if the doctor says over a 3-hour period. Well, how many drops do I need to have to get this 50 mils medication into this patient? So make sure that you answer that discussion. And then remember, your assignment is under the assignments. It is not in the back of your book. They've given you a worksheet to work. So make sure that you look at that. Again, you want to write out every step in your solution so that then I can check it. And this one talks about, especially about, for your discussion, how many minutes the doctor is saying. If we want it completed in 20 minutes, when do we start and what time are we over? I hope you guys have a great week. Let me know if you have any questions. Otherwise, see you soon.